Today, once again, welcome to today's class on integration. We have these programs on integration to solve or to see how we can solve it. Attempt all or any of the questions. Let's start with the first one. Integrate dx all over exponential x plus exponential minus. To integrate this, please note that exponential plus exponential minus x is the same thing as factorizing exponential minus x bracket exponential 2x plus 1. Please note they are the same because when you say this times this, take their common base, which is a, minus x plus 2x will give you x. This times this will now give you exponential minus. Now come to the question, integrate dx. This simply means integrate 1 over exponential x plus exponential minus x dx. They are the same. Now, we use the factorized answer and say it means integrate 1 over exponential minus x bracket exponential 2x plus 1. Okay? Dx. Now, it's also important to note that exponential 2x is the same thing as exponential x all raised to the power of 2. Noted from law of indices. So what, and it's also important to note that exponential minus x 1 all over exponential minus x is the same thing as exponential x because minus means 1 over, so they will cancel, leaving you with exponential x. It's important to note this. Now with that, we say that this means integrate exponential x over exponential 2x plus 1. That is exponential x all squared plus 1. Now, this is now integrating exponential x all over exponential x all what? Squared plus 1. It is important to note that if you differentiate tan inverse of, let's say, letter x, tan inverse of x, it will be giving you 1 over. Please note that if you differentiate this, how do you differentiate this? Differentiate x, you have 1 all over. You now say 1 plus squared. Differentiation of tan inverse of x means differentiate x, you have 1 all over. You now say 1 plus, that 1 plus you write is constant, 1 plus square the x squared. That means when you integrate this, you have this. With this knowledge now, we replace this with exponential what? X. Differentiate exponential x. Instead of 1, you write exponential x all over 1 plus exponential x squared. You write exponential x squared. Now, from law of this, exponential x squared means exponential 2x, they are the same. Now, note that 1 plus exponential x squared means exponential x squared plus 1. They are the same. So, it means that if I integrate this, I will get this. That means that integration of this simply means tan inverse of exponential x plus c. Now, going to question number 2, we are asked to integrate this. First of all, denominators are not meant to have sort. It's a rule of maths. So you have to rationalize by using the conjugate of the denominator, which is this plus this. The conjugate means opposite sign. So this is to multiply up and down. will be having 1 over 1 plus x minus x times root 1 plus x plus root x over plus x. You will now notice that the denominators are in conjugate that differed by what? Minus and plus. This gives me 1 plus x plus x root 1 plus x plus root x all over. Now, because these two are in conjugate, you say this, the first multiply the second minus the second multiply the, the first of this multiply the first of this minus the second of this multiply the second of it. This times this will give me 1 plus x. Why? Because this and this are under sod, they are under square root and they have the same number. Sod x times sod x will give me x. X minus x will go, remaining 1. So everything over 1. It means I am now to integrate sod 1 plus x minus plus sod x. That is what I am to integrate, the x. So totality of what you have here is this. Now this means integrate 1 plus x all squared, all raised to power 1 over 2 dx plus integrate sod x, integrate x raised to power 1 over 2 dx. This is because square root means 1 over 2. Now, how do we integrate this? To integrate it, you know that this, if you differentiate it, differentiate 1, 0, differentiate x, it will give you 1. In fact, your answer you got. Answer you will get when you differentiate 1 plus x will give you 1, because this is 0. Differentiation of 1 is 0. Differentiation of x is 1. So everything will be 1. If we invert 1, 1 over 1 is 1. This will be giving you, this will now be giving you that integration of this is 1 integral u raised to power 1 over 2 du plus integration of this. I've integrated this and it gives me 1. I will invert it and it still give me 1. I will now say integral 1 over what? 2, right? Now, integration of u raised to power 1 over 2 simply means add 1 to the power. It means add 1 to the power, it will give you 3 over 2. Because 1 over 2 plus 1 is 3 over 2, all over 3 over 2. That will be giving me 2 over 3 u raised to power of 3 over 2. I will note it. Now, I will come and write it here that it gave me 2 over 3 u raised to power of 3 over 2. Then I will try to integrate the second function. To integrate the second function, I will say add 1 to the power. 1 plus 1 over 2. That will be giving me what? X raised to power 3 over 2 all over 3 over 2. Okay? And that will be giving us 2 over 3 x raised to power 3 over 2. I will now say plus 2 over 3 x raised to power of 2 over 3 x raised to power of 3 over what? 2. Now, I have gotten my answer. I will not add plus c in this one Here I added plus c because this integral sign do not have upper and lower limits. So I will not put plus c in this one. I will make use of the upper and lower limit given to me. See how we do it. Now to solve it, I will write down what I got. This means 2 root u. What is my u? My u is 1 plus x. 2 root 1 plus x because of over 2. Then all over what? 3. Raised to power of 3 all over 3, please. This u raised to power 3 over 2 simply means root 1 plus x, which where u is what? X. Where u is 1 plus x. Now, you now say u raised to power 3 over 2 means square root of 1 plus x all raised to power of 3. Where the square root mean 1 over 2. Because 1 over 2 times 3 will give you 3 over 2 at the power. Then plus 2 over 3. This one can also be put at this. 2 root what? X all raised to power of what? 3. All over 3. Then you put your upper and lower what? Limit. Upper is 1, lower is 0. That means carry 1, put inside here, get your answer. And carry 0, put inside here, get your answer and subtract. Now, 1, if you put 1 as value of x here, it will give you 1 plus 1. That is what? 2. Right? 1 plus 1, 2. Square root of 2 all raised to power of 3 will give you square root of 2 times square root of 2 times square root of 2. That is 2 root 2. It will give you 2 root 2, right? Now, 2 root 2 times this 2 outside, it will now give me 4 root 2, right? All over what? 3. Plus, I'll carry 1 and put here. Square root of 1 is 1. 1 raised to power 3 is 1. 1 times 2, 2. 2 over 3, 2 over 3. Whatever I got, I come and write it here. 4 root 3 all over 3 plus 2 root 3. That is what I got when I carry 1 and put inside my answer. Then I will carry 0. 1 plus 0, 1. Square root of 1, 1. 1 raised to power of 3, 1. 1 times 2, 2 over 3. So what I got, I will just write it here. And I will say that this gave me 2 over 3. Then carry 0. Square root of 0, 0. 0 raised to power 3 is 0. 0 times everything, 0 minus 0. So everything, when it is what? 0 for here is 0. This minus 0 will give me this. Then this is when it is 0 and this is when it is 1. I will subtract the answer. Subtracting the answer, it will give me that this will minus this. When 2 over 3 minus 2 over 3, it will leave you with 4 root what? 4. When this is 4 root 2, not 4 root 3. When 2 over 3 minus 2 over 3, it will go. It will leave you with 4 root 2 all over 3. Answer. That means it gave us a definite answer. And that is why we call this definite integral. You don't put plus c, and because you don't put plus c, you means carry your upper limit, put and get your answer. Carry your lower limit, put and get your answer. Minus the answer you got for upper limit with the one of lower limit, you get your answer. Now to solve question number 3, you can see it is in compound fraction. Yes. Now, if you watch my videos on introduction to partial fraction, you will see different ways you can resolve a given compound fraction into its partial fractions. Now, if you watch that video by clicking Chidon's Daniel Introduction to Partial Fractions, you will learn a lot. Now, let's apply the knowledge here. To solve question number 1, I will say that the partial fractions are a all over, because this is raised to power of 2 and this is a linear factor. Because this is a linear factor and it's raised to power of 2, I will say all over x plus 1 raised to power of 1 plus b all over s plus 1 raised to power of 2. I have satisfied this. Then plus c all over s plus 2. No raised to power because you just raised to power 1. Now, when you have something like this, there are 3 methods of resolving a partial fraction. I need to resolve this. When I resolve it, I get value of a, b, and c. Then I will now integrate. There are methods of resolving a partial fraction. 1 is by cover-up method, 2 by comparing their coefficients, and 3 by substitution method. So we use cover-up method. We also use comparing their coefficients. All we will try to see is that we get A, B, and C. Let's see. Look for LCM. LCM of everything. These are the same. So you say x plus 1. That is their own LCM. Raised to power of 2. This have covered this. Then bracket x plus 2. This is inside this. That is why I say this one has covered this. Now this divide this. It will remain one of this. One of this divide this, it will remain one of this and this one. This times a, I will have a bracket 1 of this that remain, then bracket x plus 2, plus this divide this, it will remain this, b bracket x plus 2, then this one divide this, it will remain c bracket what? X plus 1 all square. I will say it is equals to x squared plus x plus 1 all over x plus 1 all square bracket x plus 2. This expression is something as this. That is what, from here is where we got this. Now you say, since we have a linear factor there, make that linear factor to be equal to 0. If I make x plus 2 equal to 0, I will have x equal to minus 2. I will take it and put it to these numerators. If I carry minus 2, bring it here. Minus 2 plus 2 will give me 0. 0 times this, 0. 0 times this, 0. Minus 2. Minus 2 plus this will give me 0. 0 times this, 0. Minus 2 plus 1 minus 1. Minus 1 times minus 1 raised to power of 2 will give me 1. 1 times c will give me c equals to minus 2 raised to power of 2 is what? 4. Then minus 2, then plus 1. That will be giving you that c is equals to 3 from using cover-up method or direct substitution, because we just use direct substitution by carrying this, equate it to 0 because it's a linear factor. Then when you equate it to 0, say since I've equated it to 0, that my x will be equal to minus 2, and I put it here. So that is by substitution method. I've gotten my c to be 3. I will write it up top of this part. I will now say to get my A, B, and C. To get my A, B, and C. Now, to get my A, make x plus 1 to be equal to 0. X plus 1 equal to 0. My x will be equal to minus 1. Minus 1, 0. Everything will be what? 0. Minus 1 plus 2. What will it give me? Minus 1 plus 2 is 1. 1 times b. B. Minus 1 plus 1, 0. Everything here will be 0. Then equals to minus 1 square is 1 plus minus 1 square is 1. Then x is minus 1. Then plus 1. 1 minus 1, we have it to be 0 plus 1. Therefore, b is equal to 1. We have gotten another one that b is equal to 1. And we got it also by direct substitution. We now try to get our a. To get our a, I will multiply everything and use comparing their coefficient method to get my a. I will clean. Now multiplying everything, I will have it that x times x is x squared. Then x times 2 will give me 2x. 1 times x will give me x. 1 times 2 will give me 2. 2x plus x, 3x. 3x plus 2. So I will be having 3x plus 2. A bracket x squared plus 3x plus 2 plus this one will give me bx plus 2b plus this one, to expand it, c bracket x squared 2 times x, 2x times 1, 2x, then 1 square is 1. I've expanded it. These answers we got here, please, we need to sort them out. This means a x square expanding plus 3ax plus 2a plus bx plus 2b plus cx squared plus 2cx plus what? C. We have expanded it. Now our concern is to collect those that have power of x squared. We now say we have a x squared plus cx squared. They are the two that have power of x squared. We say this equates to what? X squared. Now at this point we will be getting, at this point we will now say that a plus c factorizing is equal to x squared. This is x squared, this is x squared. The coefficients will now be equal. Therefore, a plus c equal to 1. The question is, what is your what? C. Your c is 3. Your c is 3. You now say a equal to 1 minus 3 equal to minus 2. So a is equal to minus 2. We have gotten our a, our b, our c. Since we have gotten our a, our b, and our c, we come and put it in our general formula and say a all over s plus 1. What is our a? We say minus 2 all over s plus 1 plus b. What is our b? 1 all over s plus 1 all what? Squared. Plus c 3 all over s plus 2. So we have resolved this and we say is equal to what? X squared plus x plus 1 all over s plus 2 all squared bracket x plus 2 s plus 1 all squared bracket s plus 2 dx. Now if we say we are integrating this, it means I am to integrate this, integrate this, integrate this. That's the meaning of integrating this. I have resolved them to partial fraction. It is now time for me to integrate. Now this, to integrate this, I will say bring out minus 2. That will remain integration of 1 over s plus 1. And integration of 1 over s plus 1 means ln or log x plus 1. Integration of 1 over x plus 1 means log x plus 1. So I will clean this and I will write log x plus 1. Then for this one, I will say to integrate this. If I differentiate what is inside, what will it give me? 1. Because differentiation of x is 1, differentiation of 1 is 0. Then that one I got, invert it, it still give me 1. This means 1 integral 1 over what? U squared. And that means I'm integrating u raised power minus 2 from law of indices. And that means add 1 to the power, it will give me u raised power minus 1 all over minus what? 1. Then that means my answer will be minus 1 over what? U. So if I integrate 1 over x plus 1 squared, I'll be having minus 1 over u. And my u is x plus 1. My u is x plus 1. So it will be minus 1 over x plus 1. I will clean this to write it minus 1 over x plus 1. I will say minus 1 over x plus 1. Then to integrate this next one, I will bring out this 3 out. It will remain 1 over x plus 2. Now to integrate 1 over x plus 2 is the same thing as log x plus 2. So this one will give me 3 log x plus 2. I will carry it and come and replace. I will say that this one is 3 log x plus 2. So answer is minus 2 log x plus 1 minus 1 over x plus 1 plus 3 log x plus 2. Then if you leave your answer this way, I will tell you you are wrong. Why? Because you didn't put plus c. Plus c means it doesn't have upper and lower limit. Now to solve question number 4, it is important to note that whenever you have exponential log a, the answer means a. Exponential log a simply means a. Therefore, exponential log sine x simply means sine x. Is a rule of mathematics because exponential is inverse of logarithm. They are opposite, so they will cancel out, giving you sine x. So to solve this, I will now tell them that I know that rule, and because of that, I am integrating cos. This means cos x all raised to the power of 3. They are the same thing as cos cube x, then sine x. Because I knew that exponential log sine x is equal to sine x. Okay? Now, that means I am to integrate only this. I will say let u equal to cos x. Du dx will be equal to minus sine x. Make the x subject of formula du over minus sine x. That means we are integrating by substitution method because we want to substitute this dx we have. We come here, we say this will give you integral u raised to the power of 3 sine x. What is our dx? Du over minus sine x. This will cancel this, giving you minus integral u raised to the power of 3 du. Now, what is the answer to integration of u raised to the power of 3? Add 1 to 3, you have 4 all over 4. Now you attach your minus to it. You ask yourself, what is your u? Your u is what? Cos. So cos raised to the power of 4 what? X all over 4 plus c. You attach your minus to it. That means that this one will be giving us minus cos raised to the power of 4 x all over 4 plus c. Okay, we'll go to question number 5. So integrate this. We recall that this simply means 1 minus x raised to power 8 is the same thing as 1 minus x raised to power 4 all squared. Because 2 times 4 will give you 8. I will use it and put it here. I will now say I am integrating x raised to power 3 all over square root of 1 minus x raised to power 4 all what? Squared. I will call that x raised to power 4 u. Let my u be equal to x raised to power of 4. The u dx will be what? 4x raised to power 3. Why? Because when we make the x subject of formula, this will cancel this numerator. Therefore, we have that the x is equal to the u all over 4x raised to power of 3. I'll bring it here. I will now say that this means integral x raised to power 3 all over square root of 1 minus u all squared. Because we say let this be our u times what is our the x? Du all over 4x cubed. This will cancel this. That will be giving us integral 1. Okay, we bring that 1 over 4. We bring out this 1 over 4 that remain. We bring it out. Integral 1 over root 1 minus u square du. Now, it is important to note that if you differentiate sine inverse of what you will be having, if you differentiate sine inverse of u, you will be having du dx all over square root of 1 minus u squared. Now, because of that, I will say that this will be this. So I will now say that this means if I integrate this is like saying the u all over square root of minus u squared. They are the same. So it now means because du times 1 will give you du. Now we now say that is 1 over 4 sine inverse of u. And what is our u? Our u is x raised to power of 4. Write out our answer here. We said that this means 1 over 4 sine inverse of x raised to power of 4. We'll go now to solve question number 6. Recall that 4 minus sine squared x is the same thing as divide both sides by 4. It's the same thing as 1 minus sine squared x all over 4. And the same thing as 1 minus sine x all over 2 all squared. Because sine x squared will give you sine x squared. 2 raised to power 4, 2 raised to power 2 will give you 4. We'll bring it here. We said that this means integral cos x all over square root of 1 minus sine x all raised to power 2 all squared. Now at this point dx, you say let your u be equal to sine x over 2. Sine x over 2 is like half sine x. Now du dx will give you, differentiate sine x over 2, it will give you cos x over 2. Then therefore make the x subject of formula. The x will give you 2 du all over cos x. Because this times is, this will come down. This time is 2 du, this will go up, this will come down. We carry it and come and put here. We now say this means cos x all over square root of 1 minus u squared. Right? We now say then times 2 du all over cos x. So this, I have to cancel this. We bring out the 2 out. 2 integral du all over square root of 1 minus u square. So what happened here will happen here. So this will be giving you, so this will be giving us 2. Then this means sine inverse of u, because we said that du over this means sine inverse of u. Before now we said that sine inverse of u simply means du all over square root of 1 minus u square. So this, I will say that if I differentiate this, I will get this. That is from differentiation. In differentiation, when you differentiate sine inverse of u, you get the u over square root of 1 minus u square. That means when I integrate this, I will get back this. So I will now say that because of this information, I will say integration of the u over square root of 1 minus u square will give me sine inverse of what? U. Then I'll bring out the 2 and attach it because it's at the back of it. Then what is my u? I said let my u be what? Sine x over 2. Sine x over 2. I will now say plus c. I am putting plus c because it does not have upper and lower limit. So it is an indefinite integral. But if it has upper and lower limit, please don't put plus c. We go to question number 7. It is important to note that this expression simply means integral exponential. Carry 5, raise it. Log s raised to the power of 5 minus exponential log s raised to the power of 4 all over exponential log s raised to the power of 3 minus exponential log x raised to the power of 2. And that will be giving you, because exponential is opposite of logarithm, will cancel, leaving you with x raised to the power of 5. Then this one cancel, x raised to the power of 4 all over exponential will cancel log x raised to the power of 3 minus x raised to the power of 2. Now I will say this means x raised to the power of 4 bracket x minus 1 when you factorize all over, you factorize here also over x minus 1. This will cancel this. This will cancel this, leaving you with x raised to the power of 2. That means the whole of this integration simply means I am to integrate x squared dx. I just solved this using mathematical rules and I got x squared. It means I am to integrate x squared. And integrating x squared, that means somebody might want you to integrate x squared, but he will not tell you integrate x squared dx. He will bring it in a complex way. But if you know that exponential is opposite of logarithm, you can arrive at the letters we have here and sort it out. Now to integrate x squared, add 1 to 2, you get 3. You have x raised to the power of 3 over the new power plus c. You attach plus c because it does not have upper and lower limits. We go to question number 8. Question number 8 says we should integrate this. Do you know that this expression simply means factorize 1 minus x squared dx? Yes. And this expression from difference of 2 squared, that 1 squared minus x squared means 1 minus x, 1 plus x. Okay? Then, do you know that this now will now imply that I am to integrate 1 over x bracket 1 over x bracket 1 minus x bracket 1 plus x dx. That means that what I am to do is I will say using partial fraction, because this is 1 over everything here. 1 over everything. I will now say a over x plus b over 1 minus x plus c over 1 plus x. I express it this way because all these are linear factors. So all of them will carry their letters. Then our main point now is to get our a, b, and c. To get your a, make x equal to 0. To get a, make x equal to 0. The first one, I'm using cover-up method. That means if I make x equal to 0, these two will remain, right? And this 2 is 1 minus x squared. So I'll put it into what is the numerator and put x equal to 0 into what is my numerator, 1, or what is the remaining denominator. If I make x equal to 0, I'll have 1 minus x all squared to be the remaining denominator, because this is the one I make equal to 0, this will remain. So I'll carry it and put. So put x equal to 0 into this. That will be giving 1 over 1 minus 0 squared. And that will be giving 1 over 1 equal to 1. So a is 1. Then to get b, this is what we call cover-up method. When you make this equal to 0, you carry the remaining 1, which is 1 minus x squared. Because this and this will give you 1 minus x squared. Use it to cover it up. To get b, make 1 minus x equal to 0. Therefore, x will be equal to 1. I will now, what will remain? This and this. If I make this equal to 0, I will now say my total distance is what? 1. Numerator is 1. Total denominator is x bracket 1 plus x. So carry 1 put. That will be giving me 1 over 1 bracket 1 plus 1 equal to 1 over what? 2. Right? I will say this is my b. So this is a 1 over 2 equal to what? My b. Then for my c, to get c, make 1 plus x equal to 0. Therefore, x equal to minus 1. You now say, put it into what will remain when you make this equal to 0. This 2 will remain. X bracket 1 minus x. So I'll carry minus 1 and put here. That will give you 1 over minus 1 bracket 1 minus 1. That will be giving me 1 over minus 1 bracket 2. Because minus times minus is plus. 1 plus 1, 2. That is equal to minus 1 over 2. I've gotten my a, my b, and my c. So my final resolved fraction is, what is my a? 1 all over x plus, what is my b? My b is 1 over 2 bracket 1 minus x. What is my c? My c is minus 1 over 1 plus 1 over 2 bracket 1 plus x. Then I will now integrate it one after the other. Now to integrate it, I will now say that this integration of 1 over x from logarithm from differentiation, we noted that if you differentiate log x, you have 1 over x. So when you integrate 1 over x, you get log x. Then that means integration of this is log x plus 1 over 2 integral 1 over 1 minus x. Integration of 1 minus x. To do that, differentiate what you have here. Differentiation of 1 over x. Differentiation of 1 minus x is differentiate this 1, differentiate this minus 1. It will give you minus 1. Now, please, because you differentiated this to get minus 1, invert it, because you are talking about integration. Invert it. it will still give you minus 1. You use it to multiply this. It will now give you log x minus times this minus 1 over 2. Then you will now integrate, because you have differentiated this. Let's take it again. We have differentiated 1 over, we have integrated 1 over x, and it gives you what? Log x. Now to integrate this, say let u be equals to 1 minus x. The u dx is equals to minus 1, because this is 0 and this is minus 1. Therefore, dx will be du over minus 1, still equal to minus du. I will now say that means I'll carry that minus, multiply it to half, it will give me minus half integral du all over what? U. And this means 1 over u du. So once I get this, I'll use it to come and replace this dx I have here. Once I use it to come and replace it, because all these are dx, dx, dx. So I will use minus du, which is equal to dx, to replace this dx, and that will be giving you minus du. Then that minus times this 1 over 2 will give you minus 1 over 2. Now integrate 1 over 2. Integrate 1 over u. If you integrate 1 over u, so we have log x minus 1 over 2. Integrate 1 over u, that will be giving you log u. And your u is 1 minus what? X. I'll clean and write 1 minus x. Then come to the next one we are to integrate, minus 1 over what? Minus 1 over 2 integral 1 over 1 plus x. Now integration of this, when you differentiate this, it will give you plus 1. Plus 1, when you invert it, it will still give you 1. So it will not change any sign here. Then it now means let u equal to 1 plus x. Du dx is equal to what? 1. Dx is equal to du. So I can now say that this means 1 over 2 integral 1 over u du, because I've replaced the s with the u. Then integration of this will give you 1 over what? Log what? U. And that is, your u is at this point 1 plus x. 1 over 2 bracket log 1 over 2 log 1 plus x. I will now know that what I have here is what? Log 1 plus x plus c. That will be the answer to the question. Now I'm trying to repackage. That should be the answer to the question. But you can also repackage. How do you repackage it? You say that these two, applying laws of logarithm, this will be log x minus log 1 minus x all raised power 1 over 2 minus log 1 plus x all raised power of 1 over 2. Now they have log. You bring out the log they have in common, bracket. Write your x. This minus means divide by what? 1 minus x raised power of 1 over 2. This minus simply means that this one will still come down 1 plus x raised to the power of 1 over 2 from law of logarithm. Okay? Then at this point, I will say that these two have the same what? Square root, that is 1 over 2, 1 over 2. That will be giving us log x all over 1 minus x bracket 1 plus x all raised to the power of 1 over 2. So everything all raised to the power 1 over 2. Do you know that x is something as x squared raised to the power 1 over 2 because they will cancel out? Do you know that? So repackaging, we will be having our answer to be x squared raised to the power 1 over 2 all over 1 minus x bracket 1 plus x all raised to the power 1 over 2 equals to, both of them have power 1 over 2 equal to log x squared all over 1 minus x 1 plus x everything raised to the power of 1 over 2. Then this also equals to, carry 1 over 2, bring it the other side, 1 over 2 log x squared all over 1 plus x 1 minus x 1 plus x plus c. That means answer to question number 8 is 1 over 2 log x squared all over 1 minus x 1 plus x bracket plus c. That is the answer. Then we go to question number 9. It is important to note that It is important to note that from trigonometry that sine squared x is something as sine x, and it's the same thing as 1 over 2 bracket cos x minus x 0 minus cos x plus x 2x. Sine square x will now be equal to, cos 0 is 1, will now be equal to 1 over 2 times cos 0, which is 1, minus cos 2x all over 2. So sine squared x is equal to what? This. That means we are to integrate. Integrating this means integrate this and integrate this. Integration of 1 over 2 means 1 over 2x. Then integration of this means bring that 1 over 2, which you have, integrate cos 2x. And that will be, bring that 1 over 2, differentiate 2x. Differentiate 2x, you have 4, you have 2. Invert it because you are talking about integration. You have 1 over 2. Integrate cos, you have sine 2x. So that means 1 times 1 times sine 2x. Sine 2x is sine 2x all over 4. So when I say this is minus sine 2x all over 4. Sine 2x all over 4. Now, if I put plus c, I am wrong because they gave upper and lower limit. Pi means 1/8. 180 over 2 is 90. Minus pi means minus 1/8. Minus 180 over 2 is minus 90. Now, This is upper limit and this is lower limit. I'll put it here. If I put the upper limit, whatever it gives me, I will write minus lower limit. So 90 over 2. 90 over 2 will give me 40 what? 5. 90 over 2 will give me 45 minus, I will still carry that 90 to put it here. 2 times 90, 180. Sin 180 is 0. 0 over 4 is 0. I will have 45 minus, I have put my upper limit inside everything here and I get the answer. I will now say minus, I will come to lower limit. Minus 90. Minus 90 over 2 will give me what? Minus 45. Minus 90 times 2 will give me what? Minus 180. Please note that sin minus 180 is certain as minus sin 180. It is certain as minus sin 180. So minus times minus will give me what? Plus. Then sin 180 is what? 0. So minus 45 plus 0 will give me minus 45. 45 minus this will give me 45. So 45, this will give me minus 45. Minus times minus plus 45. That will give me what? 90. And what is 90 degrees in pi? 90 degrees means pi over what? 2. So we will be getting the answer as pi over 2. We now said that the answer to this is pi over